So in previous videos, we covered what is a hash, how it's just basically an algorithm which takes data and you could say mushes it up and gives you a set output that looks the same but is a unique fingerprint of that thing. Then we spoke about the nonce, how the nonce is a piece of a block that the miners can move and manipulate in order to try and generate a different hash, in order to look for the hash that has the right signature, the right look. That nonce is something that anyone can put the same data with the nonce into their own hash and check if it's correct. And that's what nodes do. Once they receive the block from the miner, they check it themselves. And if they get the right nonce, or get the right hash, then they say it's the right block. If they get the wrong hash, they reject it. This nonce is a proof of work, it's proof that you did work and you earned that thing. And then we mentioned how each single block includes information from the previous block. So every single block right now contains effectively the summarized version and summarized piece of data of every single previous block that has come before. And it's basically say it's carrying over that value from the previous block onto the new block. And finally, we mentioned about how we can distribute that ledger or distribute these different blocks or this blockchain to multiple people in order to identify who is or has counterfeited. Today, we're going to talk about the tokens. And the token here is effectively the transactions. So when you broadcast your transaction to the Bitcoin network, miners see that transaction and they put that transaction into their own, make it their own block. But once they've, as you can imagine, the transaction itself is data. And once they've gathered together these transactions into their block, they now have to find the nonce that gives the right hash. So for example, we have Darcy gives Bingle $25. Elizabeth gives Jane $4.2627, and so on and so forth. This is the data in that block of transactions. And that's all Bitcoin is. It's data in a block defining who gave what to who. That's it. So if I was to change the amount here, rather than £25, like £25 and 1p, everything in that block is now changed. Everything in that block is now changed. So now the miner has to now mine that again in order to find the new nonce. But like we had mentioned before, he now has to, that new hash is now carried over to the next hash, which means the next miner has to also hash that again. And that one is that, oh wow, that's a long one. Oh wow, that was a massive one. So that was 227,000, blah, 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 for that nonce, for that block. And you have to see, so as you can see here, look, sometimes the mine, look at this, is just 2,000, that's really small. Some mines really quick and some mines are really small. And there's no way to know this. There's no way to know how long it takes because there's no way to know what number it is. You just have to try the numbers. Now, some miners might not go from 1, 2, 3, 4, 5. Some miners might just try random numbers and whatnot. But the point here is that's how the data works. So anyway, so we just remind that one. And effectively, if I now go in here and add that 1p, I could now take that same nonce from before or above here, and that should work over here because it's the same algorithm. There you go. So it's the same data. I use the same nonce, I get the same result. And likewise here, if I change that transaction to 1 and I change that nonce to the one that we mined above, again, it gives the right result because this is data. Hashing, put the same data in, it gives the same data out. We just need to find out what is that nonce. And then likewise, we can go ahead and we continue mining the rest of it. Oh, wow, I even thought this one was a long one. Yep, it's a long one. You get the gist. This is how you make. So now all these other chains are mined. Now what you've noticed here is just by changing this, you've noticed here, just by changing that one piece of data, I now have to remine everything else after that. Now, if we have to remine everything else after that, that takes time. So as you're trying to remine everything after that, everyone else is continuing on mining it. And this is why it's not possible after a certain point to catch up to the network and to remine a longer chain of blocks. Which is why you could mine a different chain and have different data, But number one, you'll be disadvantaged. So if you try to change this one, for example, so you've now changed this one, you've got to remind this one and then remind, sorry, I got to change the data. So here, let's change data. So I've got to remind this one. Wow, look at that, it's taking long. Oh, wow. Okay, that's that one. Then I got to remind this one, and then I got to remind this one. Whilst I'm reminding this one, everyone else on planet Earth has already continued mining the previous chain, this one down here. And that basically means that I can never really catch up to them because I myself am now competing with everybody else. So that's the reason why it takes long, why Satoshi Nakamoto deliberately made a process that it actually takes long to mine. Because by taking long to mine, it means that no one else can independently catch up and beat everybody else in the network. So yes, when the Bitcoin network first launched and it was literally just Satoshi and maybe Hal Finney mining, then it was quite easy to probably take over the network because if you just got a few more computers than them and you can take over the network yourself. But because Bitcoin has now grown, I mean, thousands of miners across the planet Earth all mining all at the same time, it's now become strong enough and robust enough to repel and defeat these kind of attempts. So we've got one last lesson to talk about what's called the Coinbase, but it's not so small, it's just a small additional piece. But we'll cover that in the next video.